Okay, so this is number 15. So the m is the largest integer such that m plus 12 to 13, m plus 37, 73 are both perfect squares. What is the unit digit of the m? Okay, so like we are given both numbers are perfect squares, so maybe we should write such a thing. So I'm gonna write m plus 12, 13 equals x squared, and then m plus 37, 73 equals y squared. So, but this is not really helpful because we have a lot of different, like, I mean, two different numbers that's kind of not nice looking. And also we have two variable, actually three variables, so it doesn't look helpful. So what I'm gonna try, I'm gonna cancel something, but easy one to cancel is the m's. If I subtract the top from the bottom equation, so we will get y squared minus x squared equals, if you subtract this, you get 0, and then you got 6, right? And then you got 5 and 2, so 25 and 5, 6, 0. This is a good at least because this is 256 times 10. 256 is 16 square. So I can write it as 2 times 5. And then this is difference of square. And then that will be 2 to the 8th power times 2, which is 2 to the 9th power times 5. So the question says find the largest value of m that does works. Like there are a lot of different m's actually satisfy this condition. And the thing is, we know that when you have the difference of squares, so each pair, I mean, each factor is actually have the same parity, which means this has to be odd and odd or even. So, but we cannot get odd and odd because that's already even number. So, which means each factor should be even. So we can take the smallest number, that's 2. If I take that, so you got 2 to the 8 times 5. If I take this is 4, so you will get 2 to the 7 times 5. If you want to get this is 5, so you got 2 to the 9 right here. So I'm trying to make it smaller. And then you got 2 to the 3rd power. So if you do get, so you get 2 to the 6 times 5. You can keep listing these and testing each one of these, but you don't really need to do that much work because we are going to actually get the answer easily without really doing all these. So when you take these, for example, first pair, okay, so y minus x equals 2, y plus x equals this number, and now we are saying that half of this number, which is going to be 1200, 80, I guess. So like when you add this, you actually cancel the x's, you got 2y, and then I can get the y by dividing that sum by 2. So that should be 1 plus 6, 8, which is going to be 681. So we got 681 for y, but this is like one of the y values possible. So if you try this one, you get something else. But the thing is, when you do this 4, then second factor is actually way smaller compared to the first one because it's just half as much. So which means this number that we got 680 to get y value, or this number, so you're gonna get the half, and then you're gonna get the half of this, which is gonna be like 2, but in the first one it was 1. So the sum is actually getting smaller. Y value is getting smaller when you choose some other values. So which means the largest number that you like to get for m is actually going to be the first pair in this case. So if that's the case, you can just go ahead and plug it right here. So you can say m plus 37, 73 equals y squared, which is 681 squared. So this is what we want. But the question is, you may just go and square and subtract this, like get the m itself, which I'm not going to do that because we are not interested in finding the value of m. We just want to find the unit digit of m. So which is why we can actually take mod 10 to get that easily. So that will give us m. So if you take the mod 10, just the remainder when you divide by 10 is just 3. And then that will be congruent to, if you take this 681 divided by 10, the remainder is 1. So 1 squared is going to be 1. So that should be mod 10. So like now we want to find what m value should I have. So you can just subtract 3 from both sides. So, or you can just see that number immediately, but that's going to be -2. And if you add 10 to this number, so you get 8, so that's the congruent as well. So which means our m should be unit digit of that m has to be 8, so that is the choice C. So that was an interesting problem, but I think it's cool. So this was number 15.